if there's something that can give context to this conversation about cost and complexity of security today, is imagine yourself having to suffer the COVID pandemic that we arguably still going through without having the internet. It would have been a disaster. Just in my case, I got all my kids that were in college. They came back into the house. By the way, that's the only positive thing that I can see about COVID. And so the internet, everybody was studying from the internet. Some of them were working. And it was full use. In fact, I had to even increase my bandwidth because of the usage. And I remember that I get one of my friends that is with me on these adventures of internet security, Polo. He said, "Hey, you know that a new version of pfSense just came out. Have you tried?" I say, "Well, I don't touch my router because if something breaks and I cannot fix it quickly, I will get evicted from my very own house." So again, very important, the internet. It's very hard to imagine a world without it. Now, what you'll see that is my common theme in all these is that there is a problem, and the problems that we have all come from the fact that security has always been an afterthought. And this is a two-part video series, so there might be a third part, but I may not make that one public. And this is the first part is going to be about the operating system and the security or lack of security. And the other one is going to be around TCP/IP, again, the lack of security or security there. Now, in the context of this conversation, whenever I talk about the words native, it's identical to something that has been put there by design. Right? In contrast, when we talk about agents and add-ons, bolted-in stuff, it's just quite the contrary, right? So let's start talking about operating system design. If you were tasked to design an operating system today, something that will not happen because we already have enough operating systems and they have grown into complexity so much that it's not really feasible to write one from scratch nowadays. Two things you need to at least take into consideration. One is access control. Who can get access to which resources, privileges, privilege escalation, all those things have to be conceived from the actual design. And the other one is encryption, because we know that some things need to be hidden from everybody's view. Encryption is required. At least those two aspects from the security standpoint you'll need to consider. And I bring those two just to show examples of things that were designed like that and things that were not. And I'm taking advantage of the fact that I've been around long enough so I remember still some of these things. Let's talk about mainframe and mainframe security. Well, maybe you don't know, but the mainframes, particularly late 70s, they were actually built on the requirement of the Department of Defense. And these folks do not mess around with lack of security. In fact, they are just the opposite of traditional business. I mean, the security is something that is very important, is considered from the beginning. And in fact, there was a book called the Orange Book that was actually a recopilation of some of those design techniques that needs to actually was, if I remember correctly, there was a certification specifying there of the things that the operating system need to do and in the way it needs to be done in order to be told that it was, I think it was C2 compliance or something like that. So in the mainframe from the early beginning, we have things like RACF to control who get access to what. There were things like encryption. There was DES. I don't know if you remember that, but that was one of the algorithms that IBM also created around that for sending information, for encrypting information. There's no Patch Tuesday mess. That thing of rushing things, and that was not the concept on the mainframe. And people may say, well, yeah, but they were not the attacks that we are seeing today, and that's not the case. I still remember that there were a lot of attacks on mainframe infrastructure. That was the infrastructure back then, coming from the Ukraine. And this is not, today's Ukraine. That was, years ago. What happened there is that in the Ukraine there were a lot of people that were mathematicians. And if you remember, back in the early days, they were not computer scientists. They were just math people. That were the early pioneers in computer science. And for some reason in the Ukraine there used to be a lot of them, and there was a lot of teachers, a lot of people that had, under the Soviet Union, that was the hotspot for mathematicians. And when the Soviet Union collapsed, well, many of these people did not have something to do, and some of them went into hacking. Of course, many things have politically changed since then, and you could argue that right now they are not as close to the Russia now as they were to the Soviet Union before. But again, there were attacks, and those attacks were very well managed, and it was not the disaster that we see these days. Although you can rightly so argue that the connectivity wasn't as prevalent as it is today. Let's talk about Unix. Definitely one of the pioneers. Remember, that was created on Bell Labs. It's a telco type of mentality. They did not, in the same way that the creators of the TCP/IP never figured that the success that this will have. Same thing with the people that were writing Unix. There was some access control in Unix, no doubt about it. I mean, there was the concept of an account, which, by the way, always existed on the mainframe. And think about it for the name account. Now, the name account, particularly in the mainframe, came from the fact that they were charged back. The more you use the computer, the more that your department will be charged for that, and for that to keep track of that, not necessarily only for security, but you have to have an account, and that's what the name, and that evolved into user ID and so on. But it used to be called account for that reason. But in Unix, it was a multi-user system, a multitasking system. The concept of hash password was there from the early beginnings, So there was definitely some considerations about security. Also, the fact that the code was known is what evolved and similar to what is today open source. And that's important in security, because that means that the code is looked by a lot of smart people, and they can attest whether and try to hack it and try to attack it to determine what is secure. One concept in security is that you cannot assume that thing is secure. You need to actually prove that. You cannot say this is secure. You need to actually withstand the test of time. But you may say that Unix lack of some native things, some design things, like encryption. I mean, hashes is, as much as I recall, but there was no encryption of centralized encryption, something designed from inside the operating system. Of course, you can actually do it. You can write a program in C and do some messing around with XORs and do some encryption. But again, it wasn't part of the operating system. It wasn't part of the initial design. And by those days, also the concept of email evolved, was created. Again, and we are still suffering from this today, no native encryption. Of course, you can do bolt-in encryption like PGP and some other, but that's like physical mail. No wonder physical, people call it snail mail, the traditional envelope type of mail, in which there's no encryption in there. I'm just relying on the fact that federal laws really, punish whoever intercept your mail, but there's no intrinsic security in it. There's no spoofing protection. I mean, you can send in the same way that you can send an email, a piece of mail, and you can put whatever you want to put on the sender address. Similar things happen, not exactly the same, but very similar thing happens with email. You cannot trust that a piece of email is actually coming. And when I talk about email, it's the traditional email, the one that was born in Unix. There are other iterations of email that added a few things in here, but in general, no encryption. Let's talk about Windows. How come we talk about security without talking of Windows? Well, remember that these things came from DOS. This was, in the early days when IBM came out with the PC. They got this guy from this Bill Gates who bought another company that had an operating system, and they start working on it. It was a single user, no security at all. It's my machine. I boot it up. I put a floppy. I boot it. It's my. So the concept of access and encryption security, none of that. And that thing evolved into NT, and a little bit of security was put in there, but was never a main point of view from Microsoft perspective. Convenience was ease of use. The concept of backward compatibility has always been key for Microsoft. And we'll see how some of these things really go against security itself, right? Again, no security. Security was always the worst type of security, bolted on. I mean, it was added. It's like you have a product, you design the product gets produced, and then, oops, I forgot this, I forgot that. So you add it into it with a couple of screws, and you tie them up and try to make it look like the initial product, but it's a Frankenstein. It's not really in the design. And we'll see the cost of that, how that affected. So as a consequence of that, we start seeing a whole bunch of agents. And again, an agent, you can use it as a synonym for, oops, I forgot to do this in the initial OS, so therefore I'm going to need to put extra code that runs on top of the operating system. It's an integral part of it, and agents proliferation that we see these days. Concepts like the TPM, which actually a more secure version is HSM, and this is the concept of the software per se. If you have a secret and you keep it on software, it's not a secret. It can be bypassed because it's software. If you have something in hardware, well, that gives you an extra level of security. You want to keep keys stored in a secure mechanism. Well, don't store them on the OS operating, the operating system supervision. Do it in a hardware, which is the hardware security modules. But even those hardware security modules, they were not that hard to bypass, and because they were not part of the operating system, maybe migration was kind of problematic. When you put those things inside the operating system, well, the migration is taken care when the new version of the operating system comes out. Let's talk about a prime example that I think can help me prove my point. Let's talk about Internet Explorer, the first browser that Microsoft came. Well, Bill Gates really missed the initial part of the internet, and when he got the importance of this, he actually catch up and rush an operating system, a browser out. Remember, those were the days of Netscape, right? So he rushed that thing in, and that has been a disaster. In the beginning, these Patch Tuesday were a whole bunch of patches for Internet Explorer, and even though Internet Explorer was abandoned in the end because it was impossible. I mean, Microsoft came to the realization that we cannot fix this spaghetti code. We cannot get this right. They started to play around with things like digitally signed pieces of software, right, to make sure that is a code that has been blessed by them. Well, that's been a joke because the management of the certificate for this, I mean, you find tons of malware these days that is digitally signed, and the OS will not say a thing. Mess with the certificate handling, and certificates not only has been an afterthought, but even the concept of certificates and certificate revocation has always been problematic. I mean, none of these things were actually well thought out. Therefore, they ditched Internet Explorer and went with the new browser, which is based on Chromium. And the folks we will talk more later, the folks on Google do care about security far more. Let's move on. I have a lot to say for part one. Let's talk about Linux. Certainly much better and open, so people can check on the code. And it came after Windows, so there's more maturity, there's more knowledge, and many more things were included and done better in Linux, but not necessarily, really part of the design. They came with it, alongside with it, more than from the initial design itself. Moving on, let's talk actually about things like macOS, which is a variant of Unix, when Steve Jobs dumped their spaghetti code on their OS and he moves into Unix as the follow-on, then a lot of things were beginning to come around security. And it can be a controversial point, but certainly Apple has a far more focus on security that Windows have, by far. Let's move on to iOS. Well, here we start to see the advantages of integration at the chip level of hardware and software. And there's a famous component in iOS called the enclave, in which it's like it's much better than an HSM. It's actually on the actual chip itself. And this has a lot to do with, well, key secrets. I wanna keep there are in the machine. Things like all the biometric stuff that first on the finger to unlock your phone, on the stuff that scans your face, all that data. You don't trust the standard software to secure that. You actually have physical hardware to do that, and that has been very successful and the way to go. In fact, the mainframe have had HSN for quite some time as well. And also here is the fact that it can be controversial these days, which is controlled downloads. I mean, in which in the Mac OS, if you want to run a program that hasn't been blessed by the folks at Apple, then you have your way of doing that. You need to go the extra step to actually approve those. But in the case of iOS, it's very controversial because Apple refuses to allow that to happen. And is security one of the main things that they argue? And they may have a point. I think whether they do it more for controlling the market and controlling their profits and getting their cut on the apps that get developed, or security is controversial at least. But the end result is that this thing is intrinsically more secure. Moving on to Android. Again, a variation of Unix. The folks at Google are very good in security. They have a very good focus, a great deal of smart guys doing that, but they lack of two things that Apple has. One is the control on the equivalent to the App Store for software that can be installed there, and from the beginning, and therefore Android has suffered from more apps that are bad that people download from that App Store. And the other thing is that because there are multiple versions of manufacturers of Android phones, then the patching is not as clean as the discipline as it is with Apple. But they again, very good folks in security. Let me make an example of why bolted security is bad, or hard at least, right? It's better than nothing, but why is it so hard? Let's talk about encryption as an example to finish this part one of the video. Well, you know that MD5 is considered today something that is breakable. So we move to SHA-1 and we increase the size of the keys and SHA-2. Well, do you know that you have migrated everything in your environment to SHA-2? You sure that you don't have MD5 running here and there? Well, you cannot say that, because first of all, you need to have an inventory. And even that is hard to be done today. There's even software that is dedicated to figure out all the type of encryption that you have today. But imagine if this would have been part of the OS. And you say OS version, boom, whatever, is going to have SHA-2. Therefore, it's going to be done across the board, and you don't have to worry about it. That's why something that is bolted in is so hard. Let's talk about quantum safe encryption. We know that with the advancements of quantum computing, security based on how hard it is to factor large prime numbers is no longer going to be safe. We know that those things will be broken by quantum computing in a matter of maybe hours, and the thing will keep going on. So in what we are relying most today, which is all that all that encryption based on prime number, large prime numbers, is going to go through the window. That's not a pun on Windows, by the way, but it's no longer going to be safe. Well, how would you migrate that? Again, if moving from a hashing like MD5 to SHA is hard, imagine moving all the rest of the inventory without breaking things. And remember that there's always a problem between security and convenience. They pull the rope in different ways. And if you put the security too high, if you pull the rope too much on the security side, then the convenience will suffer, and you get a call from upper management saying, get that thing out of the way. We need to do business in here. You are preventing that from being done. So that's what I think, that these things will not be solved. These things will keep evolving, and we will keep on doing our best to deal with them, but professionals like you that are watching this video will be always needed. And the final thought in it is, when the controversy, well, whether Mac is more secure than Windows and they get more attack and more this and that, I take a more pragmatic view on that. I'd say that definitely Mac is more secure. If you argue that the reason is that because there are less Macs than Windows, so be it. But in the end, it sees less attack. In my opinion, it's not just that. I think that it has far more security in it that Windows does. And it's the same thing as, what would you rather do? Live on a house that is a neighborhood where there's not a lot of security, but then you put bars and you put a vicious dog and you put a guy with a gate and you invest into that extra security to keep your house safe, or you move into a neighborhood in which the police do a good policing and it's a safe neighborhood, and then you don't have to invest all that money into making your house look like a jail and make it that hard. So that's my point of view. I think that in the end, if you are designing these things from the beginning and you're thinking these things from the beginning, think of all those agents, all those extra things that you need to add at extra cost, that maybe if you make a wiser decision, those are things that can be solved. I'm sure that I'm going to be seeing, even though I never asked for comments, I'm sure I'm going to be seeing a lot of comments regarding. In part 2, we're going to be talking about TCP/IP and the security or the lack of it.